Hello, my name is Lars Bode. I'm a professor of pediatrics here at UC San Diego in California, and also the director of the Mother Milk Infant Center of Research Excellence, short MOMI CORE. Today, I'm going to talk about human milk oligosaccharides, a brief introduction to what human milk oligosaccharides, or short HMOs, are, how they might benefit the infant, and what the future will look like for these human milk oligosaccharides. So let's talk about what are human milk oligosaccharides. Let's talk about that real quickly. HMOs, or human milk oligosaccharides, are complex sugars that are uniquely found in human milk. We don't find them in many other milks of other mammals, and we really only find them in human milk. And of course, we wonder, what are they doing there? How do they benefit the infant? Oligosaccharides comes from the Greek a few sugars, and that's really what they are. They are complex sugars, and there is about 150 different ones of them. In fact, human milk oligosaccharides as a group are the third most abundant component of human milk. And that is after lactose, the common milk sugar, after fat, but before protein. So in other words, we have more oligosaccharides in human milk than we have total protein. And that is very different to the milk of other species, of other mammals, especially when we compare this to cow milk, which is the basis for most infant formula. We find about 100 to 1,000-fold less human milk oligosaccharides in concentration, and there is also less structures in total. Now, unlike lactose, the common milk sugar, human milk oligosaccharides are not directly utilized by the baby. Human milk oligosaccharides make it into the stomach. They're resistant to the low pH in the stomach. They're resistant to pancreatic and brush border enzymes, make it intact in the colon. In fact, about 1% is absorbed, and we find it intact in urine. And the rest is either degraded in the colon by bacteria or is excreted intact, and we find it, in fact, in the diaper. Now, the question is, what do these oligosaccharides do? And research over the last few decades has really made big progress showing that oligosaccharides have an effect on digestion, on gut health in general, but also they have an effect on immunity, reducing infectious diseases, reducing diarrhea diseases, which are still a huge burden to infant lives. And we've also shown that some oligosaccharides synergize with antibiotics, so you would need less antibiotics to get the same beneficial effect. And of course, that's a huge advantage in the emergent antibiotic resistance crisis. We also see that oligosaccharides have an effect on cognition. And we see in the preterm space that specific oligosaccharides protect from necrotizing enterocolitis or from sepsis, which are huge problems in our preterm population. Now, how do these oligosaccharides act? What do they actually do? And how does this all work? Well, like I said, there's 150 different human milk oligosaccharides, and there is different mechanisms as well. So different effects with different underlying mechanisms. Some of these effects are mediated through the infant gut microbiota, so the microorganisms living in the gut, and some effects are independent of these microorganisms. So to just give you a summary of the different effects that have been discovered so far, first and foremost, we've seen that human milk oligosaccharides are prebiotics. So they specifically serve as metabolic substrates for potentially beneficial bacteria that then benefit the host. So they get broken down, oligosaccharides get broken down by bacteria, and the breakdown products really then benefit the infant. But we strongly believe that human milk oligosaccharides are more than just food for bugs. We've seen, for example, that they do exactly the opposite to other bacteria that we don't want. So they have antimicrobial effects by either stopping the growth of certain pathogens or killing them entirely. We've also seen that human milk oligosaccharides have anti-adhesive effects. And that means that many pathogens, or bacteria in general, really, need to attach to the epithelial surface in the intestine to be able to proliferate and cause disease. Now, this attachment is often facilitated by bacteria binding to sugar molecules, the glycocalyx, on epithelial cells. And it turns out that human milk oligosaccharides resemble some of these glycocalyx structures and serve as soluble decoy receptors. Now, bacteria bind to soluble human milk oligosaccharides instead of binding to the epithelial cell structures. And since they no longer can attach to the epithelial cells, they get washed out without causing disease. In addition to that, we see that human milk oligosaccharides have direct effects on epithelial cells in the intestine, strengthening, for example, barrier function and many other things. They also have effects on immune cells locally in the intestine, but since they get absorbed, they also have potential effects on immune cells on a systemic level. And we strongly believe that this is just the beginning. There's so many other effects to discover. Like I said, there's 150 different molecules, 150 different opportunities to study the effect on milk oligosaccharides. And that's really where the future is. So the future from a researcher's perspective is trying to answer what maternal factors drive human milk oligosaccharide composition. That's different between different moms at different time points. What really drives the synthesis of these human milk oligosaccharides? On the other hand, of course, we want to know what different oligosaccharides do to short-term infant health, but also long-term infant development. And last but not least, we are able to understand mechanistically how these oligosaccharides work, and then take that knowledge and develop new diagnostics and therapeutics, not just for infants, but potentially also for adults and people of all ages. Now, from a practical perspective, we're trying to understand what individual oligosaccharides do in different contexts. So which oligosaccharide is most important when it comes to cognition, or which one is most important when it comes to gut health? And in addition to that, is it possible to blend different oligosaccharides together to get an even better effect? And last but not least, of course, we're trying to understand how can we scale up oligosaccharide synthesis and bring the cost down so we can make oligosaccharides available in different products to different infants that cannot be breastfed. And you see there is lots of work still to do and to discover. This is a really exciting field, and I hope this was a good introduction to give you a little bit of a teaser what human milk oligosaccharides are and what their potential is for infant health and development. Thank you.